We will now touch on descriptive statistics. We have to have a good understanding of the distribution of our data and what our data looks like before we can start to answer our research questions. So to better understand our data, we do two things. We look at the data numerically using values such as means and standard deviations, percentiles, medians, and we can also explore the data using graphs like histograms and box plots. I will show you how to do this in Jamovi using our data set from James et al. 2020, but we will use a smaller data set, or rather only look at some variables, which are on the screen now. So we'll look at the age group, school year, age in months, gender, vocabulary, see top phoneme elision raw score, 6 morphological awareness tasks, and an MA factor task. So the factor score is generated from a principal components analysis. What that does is it looks at all 6 of these morphological awareness tasks and highlights the variance of interest, or the shared variance that best explains morphological awareness. And finally, as our outcome variable, we'll be looking at predicting reading comprehension. Okay, let's see how to use Jamovi. So Jamovi will open. Remember, we're using our dataset post-imputation saved as a Jamovi file. To explore the data, we choose the top left button called Exploration. You'll click on the Descriptives tab. Now I want you to be able to see better, so I'm just going to click this border and drag it across. So to remind you, before you get to the stage, you need to make sure your data set is all set at the right levels, which we have already done. Let's see what Jamovi can help us do. Let's just look at age group. I'm interested in understanding how many people's data do we have for this variable. And so what we can see if we look at n, which is the sample size, is that there's 421 participants. But then I have all these numbers which don't really make sense. If you remember, age group had a value of 1, 2, or 3, which corresponded to the group of, or the age band that the children were in. So it doesn't make sense to look at the numbers like that. So how we change it is we go to statistics and we uncheck mean, median, minimum, and maximum. Because what we're just interested in knowing is how many children participated in the study. Let's quickly look at the statistics tab. We can ask for sample size and the number of missing values. We can look at percentile values split into quartiles, which is 25th, 50th, and 75th percentile. Or we can tell it that we want a specific number of groups, for example 10. We can look at dispersion, standard deviation, variance, range, minimum, maximum, and standard error of the mean. We can look at our measures of central tendency, mean, median, mode, and sum. Distribution of skewness and kurtosis. And finally, a Shapiro-Wilk test to test normality. Where do we find plots? Just in the tab below, where you can choose from histogram, density, QQ plot, box plot, violin, dot plot, and a bar plot. Another option when we look at categorical data, such as age group, is to get a frequency table. This will tell us how many participants in the counts were in each level of this variable, as well as the percent of total. Alright, so I can see there's a fairly even distribution of participants in each of the 3 age bands. Let's now also add gender. So click on gender, move it into the variables box. We can see that these tables automatically update. Gender was also answered by 421 participants, and we can see that there are more females than males. 54% of females, 46% male, but it's quite close to 50% either way, so it's quite nicely balanced. Now let's look at our continuous variables. Let's get rid of these variables by clicking them and moving them out the box. Let's remind ourselves what our variables are that are of interest to us. Age, vocabulary, each time I click it and I move it across, the raw score for phoneme elision, and all our morphological awareness tasks. How you pull that across quite easily is you click on the first one, you hold down Shift and you click on the last one and then move it across. Next, let's edit what statistics we want. It's always a good idea to get the mean and the median. Although we don't report the median most of the time, it's nice to know when we're exploring our data. We can then look at our minimum and maximum values. We didn't collect this data, so possibly we don't have an idea of what the possible maximum is. And standard deviation should always be selected. In some journals, they would prefer you to report standard error of the mean, so we'll just include that for now. So there's our table with our variables of interest. We can see that there was no missing data for any of them. So let's uncheck missing to make our table neater. This is where we see our information on the mean. And I can see I've made a mistake. I've used the scaled score here when I should have used the raw score. It's not a problem. You can simply go and put it back in. It's nice to compare the mean and the median values because it will show you how symmetric your data set is. So if we look at the mean for age and the median, it's very close, so it's quite a symmetric distribution. Same for vocabulary, 26 and 27, and the morphological awareness tasks. And we actually see for all these tasks, there's quite a nice normal distribution. Well, it looks like anyways from our numerical values. How can we tell if that's the case? Well, one of the easiest ways to tell if data is normally distributed is to look at a histogram. So we go to the plot section and we click on histogram. That generates on the side. So we can see here that age seems to have 3 distributions. This kind of makes sense if you think about the data that was collected, where it was for different age groups of children. So we wouldn't expect there to be a lot of overlap. If we look at vocabulary, we can see there's quite nice of a bell curve, except there's probably a few points missing on the right. And for your morphological awareness tasks, we can also see that the peak is quite close to the maximum score, which means that the test was possibly too easy. For example, this morphological awareness task, MACA. Alright, so now we can see the distribution of the data. Another way to look at the distribution is to use box plots. So let's click on box plot. So now we've generated our box plots. We must think to ourselves that it's not really reasonable to generate a box plot for age, given that it was collected for 3 different groups of children, where there's definitely no single distribution. So let us just disregard this box plot for now. If we look at vocabulary, we can see that there's a nice spread of data, there's no outliers. This morphological awareness task seems to have a few outliers at the bottom end of the distribution. There's 2 outliers for this morphological awareness task and a few outliers for this morphological awareness task. So if we look at the histogram and the box plot together, we can see how they support each other. If we look at the histogram, we can see that many scores are at the top end of the distribution, which makes it seem like this task was too easy. And if we look at the box plot, we can see that that is the case, that 50% of the data lies higher than 23 for this task, which is out of 25. But there are few children who did perform much lower who are at the bottom end. So we can explore all these box plots. And we can see that those outliers is probably the reason why the original authors of the study decided to have a factor score so that all the variation would even out. But we can even see, looking at this factor score, that it's not necessarily a normal distribution either, and it definitely have at least 3 outliers at the bottom end of the distribution. I won't do it for everything, but let's also look at a violin plot. This is a violin plot. We clicked it here on the left. A violin plot plot basically overlays a box plot and acts as a sort of density curve to show you where most of the data is. So the further away these lines are, the more data is over there. And the closer together the lines are, the fewer data points there are. We can confirm this by using the data option. Where the dots are very dark, there's more data points there. And this coincides with the violin plot being further away. Just remember, you're not necessarily going to paste this figure into a report that you're writing. It's more something that you complete in the stage before doing your inferential data analysis. Let's now also explore a QQ plot for the vocabulary variable. What the QQ plot does is it graphs standardized residuals on theoretical quantiles. And what you want to see is that your black dots are close to this line here. And we can see that it's mostly on the line except for the tails, which corresponds a bit to our histogram. Finally, let us look at a density plot. This is another way of representing a histogram, but without using bars. So this density plot basically shows us where most of the data is. It's around the 20 mark, and it's another way of representing a histogram without the biasing effects of the bins of a histogram. Let us examine our outcome variable, the comprehension variable. Let's get rid of all of this. Just press the left arrow. And our comprehension variable is called YarkCompAb. Let's bring it across. And it's going to generate everything the same for us. Our mean score is 57, our median is 58. So if we just look at the numerical values, we would think there's a normal distribution. If we look at our histogram with the density plot overlaid, it's quite a nice, almost bell curve. Again, the top score was maybe too low for the high achievers. And we can see from our box plot that except for the outliers, it's a very nice distribution. Same with the QQ plot. We can see that at the tails, the data deviates from normal, but for the most part, it follows the normal line. For the last thing we're going to do in this video, we want to see if comprehension differs by age group. So we can also do that in descriptive statistics. Leave your comprehension variable under the variable box, and then we're going to split the data by age group. I don't want all these plots. I actually just want a box plot and violin plot. So let's get rid of the other plots. Let's get rid of standard error of the mean, as well as the median. So what do we see if we look at this numerical value for mean? That the 6 to 8-year-olds have a lower score than the 9 and 11-year-olds. But the 9 and 11 and 12 and 13-year-olds seem to have almost a similar score at 60 and 61. What does differ though at the older age group is that the variance decreases slightly. And our minimum value increases per age group. But the maximum value seems to not really depend on the age group. If we look at our plots, we can see how the 6 to 8-year-olds overall perform much lower than the other age groups. And the difference between the 9 and 11 and 12 and 13-year-olds seems to only be the children at the bottom of the distribution. We hope that you now understand how to generate descriptive statistics using jamovi, and that you can interpret the results from the numerical as well as graphical output.